For 13.1a, there is a way to solve these problems using the Pythagorean identities that you'll learn in 13.1b. But I think there's an easier way to do these if you can remember the bow tie rule. So the bow tie rule tells you how to draw a triangle depending on which quadrant you're in. All right, so looking at number 1 and also number 2, we are in quadrant 1. So we want to draw the triangle kind of like this. So using the positive x-axis. All right, so I'll sketch the axes. And I made quadrant 1 the biggest because our triangle we know is in quadrant 1. All right, you always put theta close to the origin. And so if tangent of theta is 4/3, we can put 4 on the opposite side and 3 on the adjacent side. And that's a 3, 4, 5 triangle, so the hypotenuse has to be 5. And now we just have to find cosine of that angle. So now we do adjacent over hypotenuse, so that will be 3/5. For number 2, we draw another quadrant 1 triangle. Theta goes here. Sine is opposite over hypotenuse. All right, so we have to use the Pythagorean theorem to find the other side. 3 squared plus the unknown side squared equals 7 squared. So 49 minus 9 is radical 40. The square root of 40 is 2 rad 10. So now we do opposite over adjacent. But you can't leave a radical on the bottom. So we get 3 radical 10 over 20. All right, when we leave quadrant 1, you have to remember ASTC. So when we leave quadrant 1, in quadrant 2, sine is positive, cosine and tangent are negative. In quadrant 3, tangent is positive, sine and cosine are negative. And in quadrant 4, cosine is positive, sine and tangent are negative. All right, so now they're telling us we are in quadrant 2. So I'm going to draw a quadrant 2 triangle. Make sure you use the x-axis and you never use the y-axis. Cosine is adjacent over hypotenuse. You could put 7 because length can't be negative. I like putting the negative. All right, hypotenuse is 8. 8 squared is 64. 64 minus 49 is 15. So this side is radical 15. All right, and now I'm realizing I didn't need to do all that because secant is just the reciprocal of cosine. So we really didn't have to do the triangle at all. All right, number 4, we are still in quadrant 2. All right, cosecant is the reciprocal of sine, and sine is opposite over hypotenuse, so this is hypotenuse over opposite. So let's put 12 on the hypotenuse, 5 on the side opposite theta. That is not a 5, 12, 13 triangle because 13 is not on the hypotenuse, 12 is. So we have to do 144 minus 25, which is 119, then take the square root of that. Tangent is opposite over adjacent. So for this one, we want adjacent over opposite. Also notice the x-coordinate is negative, so I'm going to put a negative on this one. Adjacent over opposite. And by ASTC, sine would be positive, and so would cosecant, but the other four would be negative, and we got a negative answer. All right, 5 and 6, we are in quadrant 3. So I draw the triangle in quadrant 3 using the x-axis. All right, cosecant is hypotenuse over opposite. I'm going to change this to a fraction. So hypotenuse over opposite. And I'm going to give the y-coordinate the negative because I know that points in quadrant 3 have a negative y. All right, using the Pythagorean theorem, 4 minus 1 is 3. So this has to be radical 3. And that's a special right triangle. 1, rad 3, 2. Cotangent is adjacent over opposite. We know that this is also negative, so adjacent over opposite, and we could simplify that to just rad 3. And this goes in line with our ASTC. So ASTC says tangent is positive in quadrant 3. And if tangent is positive, then its reciprocal cotangent is also positive. All right, drawing a quadrant 3 triangle. So I know my answer is going to be positive because of ASTC. Sine is opposite over hypotenuse. And this is a 5, 12, 13 triangle. And I know that the x is negative, and so is the y. All right, so I do opposite over adjacent. And I didn't bother writing the negatives because they're going to cancel out. And also because using ASTC, I know that tangent is going to be positive. All right, 2 more. Now we're in quadrant 4. Cosine of theta is 6 over 7, so adjacent is 6. That's an x-coordinate, which is positive. Hypotenuse is 7. I can tell the y-coordinate is going to be negative. I square 7, that's 49. I square 6, 36. 49 minus 36 is 13. So this is radical 13. And I can put a negative with it because it's a y-coordinate. Right, and now I do opposite over hypotenuse. And then just double checking ASTC, we know that cosine is positive, but sine will be negative. All right, cosecant is hypotenuse over opposite. So hypotenuse, opposite. I know the y-coordinate is negative. All right, we square 81, and we subtract 16. We get 65. All right, and then I just realized I made the same mistake I made earlier. Sine is just the reciprocal of cosecant. So sine of theta is going to be -4 over 9.